Hello, good day viewers. In this tutorial, we are going to evaluate these expressions. They are all expressed in summation form, and we're going to find that exact value that represents the summation. Let's get started. The first one, we would like to evaluate the summation of k, where k starts from 1, stop at 13. So the first question, we would like to evaluate the summation of k from 1 down to 13. In this first tutorial, we are going to do that directly, but subsequently, I will show you how to use formula in doing that. So when k is 1, we have 1 plus. When k is 2, we have 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12 plus 13, because you keep on increasing the values. So this is exactly what it means. And if you add all of these numbers together, you must get 91. So subsequently, I will show you how to use formula in dealing with these problems. So we say that this is equal to 91. Let's come to the second one. We would like to evaluate the summation as k equal to 1 down to 6 of this given expression 3k plus 3. So when k is 1, we have 3 times 1 is 3 plus 1 is 6. So we have 6 plus. When k is 2, we have 3 times 2 is 6. And 6 plus 3 is going to give us 9 plus. When k is 3, we have 3 times 3 is 9. And 9 plus 3 is 12. But just observe the pattern. We have this plus 3, this plus 3. If you keep on adding 3 to this, you get the subsequent terms. Plus 15, 1, 2, 3, 4, plus 18, plus 21. I think they're all, because we have 6 times. 1, 2, 3, 4, 5, 6. And if you add all of these numbers together, you get 81. Which means that this summation is equal to 81. Let's come down here. So the C part, we would like to evaluate the summation of k squared from 1 down to 6. If you take 1, you square that. You take 2, you square that. You take 3, square that. You take 4, you square that. You take 5, you square that. You take 6, you also square that. This is what it means. For which k begins with 1 and stop at 6. That's what it means. So this is 1 plus 4 plus 9 plus 16 plus 25. All of these are perfect square numbers. And if you add all of this together, you get 91 as well. So this is equal to 91. I told you subsequently we are going to be dealing with these problems using formula. They all have particular formula used to evaluate them. So let's take the last one, the D part. We would like to evaluate the summation of sine n pi divided by 2, for which n begins with 0 and stop at 6. For this one, since it is a trigonometric ratio, let's use cycle, unit cycle. The coordinate here is 1, 0. The coordinate here is negative 1, 0. Then the coordinate here will be 0, negative 1. This is 0, 1. And the values, I think this is pi. This is 3 pi divided by 2. This is pi divided by 2. This is 0, 2 pi. Okay, let's get started. When n is 0, you see we have 0 times pi is 0 divided by 2 is 0. So sine of 0 is here, which depends on y coordinate, which is 0. So we have 0 plus. When n is 1, you plug it here, you have 1 times pi is pi divided by 2. So we have pi divided by 2, which is right here. You see that? This is pi divided by 2. Sine of pi divided by 2 is 1. So we have 1 here. When n is 2, we have 2 times pi is 2 pi divided by 2 is pi. And this is pi. Sine of pi is 0. plus. When n is 3, we have 3 pi divided by 2. This is 3 pi divided by 2. The sign of 3 pi divided by 2 is -1. So we have -1. It keeps on rotating. You see, this is going to give us 0. This will give us 1. Let me see. There should be 7, right? From 0 to 6 is 7 times. 1, 2, 3, 4, 5, 6. We have 1 more, which is 0. So let's add all of them together. 0 plus 1 is 1. Plus 0 is still 1. Minus 1 is 0. Plus 0 is 0. Plus 1 is 1. Plus 0 is still 1. So this evaluates to 1. As simple as this. So subsequently, we are going to be using formula in determining the summation of this series. Thank you for watching.